All right, let's dig in. You know how we usually dig tunnels?
Yeah, giant machines, tons of noise, lots of dust.
Exactly. But what if there was a different way? What if we could create tunnels with just, well, waves?
Waves, I've heard of sound waves breaking glass.
Right. But think like even more powerful. Today's deep dive is into a paper that proposes using waves to tunnel through rock. Yeah, no heavy machinery, just physics. The paper is, get this, wave-based rock tunneling, a theoretical model by L.S. Larkey, a theoretical astrophysicist.
An astrophysicist. Huh, interesting.
Yeah, it's kind of out there, right? I mean, it's not every day you see cosmology and tunneling in the same sentence.
So how's an astrophysicist qualified to talk about, digging holes in the ground?
Well, this paper, it's not about just digging. It proposes tapping into something called the fractal vacuum, like a web of energy connecting everything, using special magnetic fields.
Okay, so we're not talking about like sound waves or something. It's something else.
Exactly. It's about using these subtle magnetic fields, SMFs, to target this fractal vacuum and weaken the bonds holding the rock together. Think kind of like making the rock temporarily unsolid.
Like dissolving it.
Kind of. More like gently pushing the atoms out of the way.
So I guess like a device would emit these waves, kind of a super-powered sonic drill, but using these SMFs instead of sound.
Yeah, you're getting it. The paper actually describes a ring of coils emitting a specific magnetic field pattern and a waveguide chamber to focus those fractal waves.
A waveguide chamber? What does that do?
Think of it like making sure the waves hit the rock perfectly, no distortions. Kind of like a high-tech sound studio for these fractal waves, making sure the signal is clear.
This is all sounding super complex, but are we even close to actually building this thing?
Well, that's the thing. The paper is, as of right now, purely theoretical. Lots of equations and concepts, sure, but it needs a lot more research, actual experiments.
So, what are some of the biggest roadblocks you see?
Well, for one, generating these SMFs and controlling them precisely. We're talking atomic level stuff here. Any tiny error could mess everything up.
Yeah, and I imagine the energy needed to, generate these fields, that's got to be huge.
Right. You can take massive amounts of power. We're talking a whole new level of engineering and probably some new scientific discoveries, too.
But what if it worked? What could we do with this kind of technology?
I mean, imagine tunnels with almost zero environmental impact, drilling on other planets without needing to send huge, heavy machinery.
Wow. Yeah, that'd revolutionize everything from construction to space exploration. We'd have to think about things completely differently.
Exactly. But before we get too carried away, we need to take a closer look at, well, the theory itself. How does this fractal vacuum actually interact with matter? How do these waves actually weaken rock? That's where we'll pick up next time.
That's for sure a deep dive I'm looking forward to.
It's going to be a wild ride. Stay tuned.
It's funny. When we think tunneling, we think like brute force, but this is like manipulating space itself to make the tunnel, right?
Yeah, and that's where Larkey, being an astrophysicist, it actually makes sense. Like taking these huge universal ideas and applying them to, well, digging a hole. Pretty wild.
It really makes you think maybe there are connections between like the biggest stuff out there and tiny particles we haven't even figured out yet.
Absolutely. Okay, let's get back to how this wave boring thing would actually work. We talked about the coils in the chamber, but can you break it down a little more?
Sure. So picture this. You've got these coils creating SMFs, which are like big but super weak magnetic fields. They're like a sculptor's hands shaping this fractal vacuum wave, guiding it, focusing its energy onto a very specific point in the rock.
I'm trying to picture the scale here. Huge but weak magnetic fields messing with stuff at the atomic level. That's a lot to grasp.
It's mind-bending for sure. And that's why the paper keeps saying how important precision is. Think of the SMFs like a conductor leading an orchestra. If they're even a little off, the whole thing falls apart. The harmony of the fractal wave gets messed up.
So create a super precise magnetic field, then use it to shape this fractal wave, which then weakens the rock.
Got it. Exactly. It's a delicate dance, and that's where the waveguide chamber comes in. It keeps that dance going, protects the fractal wave from anything messing it up.
Like making sure there's no Wi-Fi signals or anything interfering.
Exactly. The waves need to hit the rock perfectly clear and focused, like a clear radio signal.
All this, and we haven't even talked about how much energy this would all need.
Right, that's a big one. Generating and controlling these SMFs, shaping the waves, keeping it all stable, it's going to take a ton of power.
The paper talks about advanced engineering, breakthroughs in energy storage even. Sounds like we'd need a whole new energy grid, honestly.
For sure, it's way down the line, but that's part of what makes it exciting. It forces us to think beyond what we can do now. Imagine a future where we control energy and matter in crazy ways.
Okay, let's imagine that future. We've got the energy, the SMFs, the whole device works. What does that world look like?
Well, first off, construction and mining, completely different. Imagine tunnels, quiet, efficient, no messing up the environment.
No more giant drills tearing up the earth. We could build underground cities, transportation, everything.
Exactly. And space exploration. We could send a small device, build habitats on other planets without lugging heavy equipment around.
Building a moon base would be way easier.
Totally. It changed how we think about space travel, colonization, everything. Imagine shaping the ground on another planet to build what we need. Crazy.
Sounds amazing, but is it too good to be true? I mean, a lot of stuff we have now seemed impossible a while ago.
Right. It shows that what's possible is always changing. So this wave tunneling, as crazy as it sounds, it's worth looking into.
It shows how science works too. An idea about the universe could lead to a new way to, well, dig a hole.
Speaking of the universe, the paper dives into this fractal vacuum idea, how it works with matter at the atomic level.
This is where it gets really complicated, yeah.
Yeah, it gets deep into physics, but we can try to make it simple. Imagine the fractal vacuum as like a cosmic ocean of energy everywhere. And it has waves, not water waves, but energy waves.
Okay, I'm picturing this energy ocean, waves rippling through it. But how do those waves mess with, like, solid rock?
Well, the idea is this fractal vacuum, it interacts with matter at the most basic level, affecting how strong the bonds between atoms are.
So the waves are playing with the forces holding everything together.
Yeah, exactly. And if we can control these waves with SMFs, we can weaken those bonds, make the rock less solid.
Instead of smashing through, we're using the waves to, convince the atoms to move.
That's a great way to put it. Find the right frequency to resonate with the rock, make it loosen up.
The paper has some heavy equations to explain this, but it's all theoretical, right?
Right now, yeah. It's like having sheet music but no instruments. We need to test it to see if this bond weakening actually happens and if it's strong enough to be useful.
Which brings us back to, can we actually build this? Even if the theory is good, can we make a device that creates these magnetic fields, shapes the waves, and controls it all perfectly?
That's the big question. It'd be a huge engineering challenge, needing breakthroughs in a bunch of fields. New materials, new energy stuff, new ways to control it all.
We're talking like inventing the computer, splitting the atom, kind of big.
Maybe even bigger. We're talking about shaping reality itself.
It kind of makes you realize how much we don't know about the universe, huh?
It's humbling for sure, but it's also really inspiring. Just the fact that someone's thinking about this stuff, pushing the limits of what we thought was possible, that gives me hope.
It shows that exploration and discovery are still going strong. Who knows what crazy stuff we'll figure out if we keep asking what if?
Makes you wonder, what other crazy ideas are out there just waiting for someone to think of them?
For sure. And this one really makes you think, right? Tunneling. We always thought brute force. But Larkey's saying, no, do it subtly, almost elegantly.
Yeah. It's like we're sculpting reality, you know? Instead of breaking through, we're nudging the atoms, making space for the tunnel.
That's a good way to put it, like asking the rock to move aside, please and thank you.
Exactly. And imagine if we could control matter like that. I mean, it'd change everything, right?
Everything. Construction, mining, how we get around, even energy maybe. Think
Okay.
about it. Underground cities. No need to mess up the surface. All the resources we need without, the damage mining does now.
Totally. We could rethink cities, how we manage resources, everything. And then space, think about that. Habitats on other planets, we just shape the ground to make what we need.
Building a moon base suddenly seems a lot simpler if we don't need to haul tons of stuff there.
Right. It opened up space exploration so much, maybe even living on other planets for real.
But, this all depends on, one, the theory being right, and two, actually building it, which seems a bit challenging.
Yeah, for sure. Like we talked about, challenges everywhere, from making these magnetic fields to figuring out how different rocks would react to this wave thing.
And the energy, right? Powering these devices, especially on other planets where we don't have, power plants just lying around.
True, true. But even with all that, the payoff is so big, we gotta at least try, right? This could change how we deal with the physical world, completely.
It's almost like we're talking about a whole new science, going beyond atoms to, shaping space itself.
Yeah, it's humbling to think we're just starting to figure this stuff out. This paper, it's like a window into a future where, I don't know, maybe anything's possible.
It reminds you that science is always pushing forward. What seems impossible now, tomorrow, who knows?
And it starts with being curious, asking questions, imagining things that seem crazy.
So everyone listening, keep asking those questions, keep exploring. Don't be afraid to think outside the box, right?
Yes.
Maybe you'll discover the next impossible thing.
And who knows, maybe that'll be because of an astrophysicist who thought about digging with waves.
Thanks for joining us on this deep dive, folks. Hope it got you thinking. Until next time, keep exploring the universe. You never know what you'll find.